Good morning, Year 12. Today we are looking at Annuities Part 2. So this is going to cover the rest of exercise 7A. So it's mostly looking at filling these annuities into tables. Annuities and tables is very common in the HSC, however, not these tables so much. There's going to be some tables we look at in the next couple of lessons which are highly common. In fact, I've never seen a question set out like these tables in the HSC, but they are in the exercise, so they definitely means they can be in the HSC. Now I'm just going to change that. Sorry, that should be 18.8%. Okay, I have two table questions, one for a loan and one for your savings. Okay, because we looked at last lesson that there was two different formulas for each one of those. Okay, so let's look at this first question. It says Lance contributes $350 a week into a savings account. The initial value of that account was $2,000 and he earned 18.8% interest per annum. First wants us to write a recurrence relation for that and then fill in the table. So what does that mean? Okay, so he's opened this savings account, he's put $2,000 into it. Now he's going to add $350 every week into that savings account. And he earns interest on that savings account at 18.8% per year. So the first thing I'm noticing is I've got week here, but I've got year here. So I must turn them both into week. So I'm just going to divide my 18.8 up by 52. And don't forget, I need to also divide that answer by 100 to get it out of that percent. I'm going to go ahead and do that now. Okay, and just for the sake of this question, and again, they usually will specify in some sort of exam question, but I'll just round it to, 5dp. Okay, now my recurrence relation, okay? It's very similar, remember we said, to that compound interest formula we've seen before, like that, okay? But what's happening is you're also adding that down payment each time. So remember last lesson, that's how we came up with this formula here. So the future value we've turned into this Vn plus 1 is equal to the present value, which is the initial value, times by my percent. Now remember, whenever we use our compounding interest, we need to do 1 plus the rate, okay? Now to the power of n, well, this is just a recurrence relation, and our power is always just going to be our value, but the idea is you don't have to worry about the power when we're looking at the recurrence relation. We're just multiplying that initial value by the percent, so it's going to be 1.00362. okay, so note there I just did 1 plus my 0.00. okay, so just remember you need to do 1 point, not just the 0 point. Then plus on your down payment, okay? And that there is the recurrence relation written for this question. That is definitely something you need to know how to do, okay? So the big thing is just remember this formula and just remember your percent. You need to do 1 plus when you're putting that value in. Okay, now we have the recurrence relation. They just want us to fill in this table. So remember, Vn is the original value at the start of that time period. So this is saying, okay, well, at the end of the first week, what's in that account? Now we're filling into the table, which means our Vn, our original amount in the first week, was just at $2,000. It was already in there. The down payment we're making is $350. So now we use both of those things and we find what that's going to be at the Vn plus 1, which means we're just going to substitute, now I'm just going to get rid of some of this writing, substitute both of these values up into my recurrence relation. So in other words, I'm going to just do $2,000 timesing by 1.00362, and then I'm going to plus on my $350. That leaves me with an answer of 2357.24. Okay, so that means at the end of the first week, that's how much money is in there once he made that down payment of $350 and it earned interest. Which means you could look at this and say, well, you can see straight away he earned $7.24 in interest, okay, that week, because he only added $350 of his own money into the $2,000, but it's accumulated to this amount. So what do we do now? Now we bring that value, and it's now the initial value for the second week. Hence why we call it that recurrence relation. The down payment is going to be always $350, so you can assume $350 all the way through. And now we're going to plug our new two values up into the recurrence relation. So this time, and I just leave that number up on my calculator from the answer before. So then I can just put times 1.00362 and plus the 350. So at the end of the second week, Lance has $271.5.773209. Okay, and then again, you're going to bring that answer back here, back down to the start of the third one. So if you want to, pause the video here and finish off the table yourself. Otherwise, I will keep going ahead. Alright, now we're going to sub in both of those values. Times by 1.00362 plus 350, 3075.604308. Keep bringing it down. Times that by my amount. And there we have it. So I filled in my recurrence relation table. So this table actually explains a lot, okay? It explains how much money is in the account at the end of each one of those weeks. And we could have kept going to the 5th week, to the 6th week, and you have to keep using that answer from before. So the big thing to take out of these types of questions is if they ask you, okay, well, what's going to be in the savings account of Lance's after 6 weeks? You have to do all 1, 2, 3, 4, 5 weeks as well. You can't ever skip straight to the 6th week because you need the 5th week's answer to use in the 6th week. That's the definition of a recurrence relation. So now you're going to do the exact same thing, but this time it's a loan. And we know with loans that you subtract off the down payment because the loan recurrence relation formula tells you what's left owing on the loan at each one of those weeks or months or whatever the value is in terms of. So if you want to pause the video and give this one a go on your own, go for it. Otherwise I will go through this one a little bit quicker, but Jan has a loan of $46,000 in an account. It charges 3.88% in interest, I should say. If she makes yearly repayments of $12,000, and I didn't mention this either, we'll make that per annum. Right, a recurrence relation. So everything is in years, so I don't have to change any of that value. I can just sub straight into a recurrence relation. Vn plus 1 is going to be Vn timesing by my rate. Now remember, I need to turn this rate into a decimal, so it's going to be divide that by 100. And remember, when you sub into the formula, do 1.0388. Then subtract off the amount they're paying, $12,000. Okay. So now let's sub it in. The initial value of the loan, $46,000. The down payment is $12,000. So she's paying a large chunk off. She might even get this paid off in 4 years. Okay, subbing those values straight into my recurrence relation. I'm going to do $46,000 times that by 1.0388, and then subtract off my 12,000. So at the end of the first year, she's left owing $35,784.80. Now I'm going to bring that value down. That's the original value in the account at the start of the second year. The down payment is always at $12,000. And I put those values in. So I'm going to pause the video here and just fill in the rest of the table, give it a go and see what you get. Alright, I've gone ahead and filled in the rest of the table, and you can see hopefully that at the end of the fourth year, Jan only owes $2,698.99. So hopefully you can get that deep understanding of what each one of those levels mean, and you got those answers correct. Okay, so there's a bunch of questions in your exercises that just get you to fill in tables like that. It kind of just structures it all for you, I guess. The last thing I want to do is just look at some of those level 3 questions in the exercise, and it basically it looks at the same sort of question this time but without the table. So we've got Ellie, she takes out a loan. Okay, so straight away you're thinking in your head, loan. I know the formula for the loan is going to be my VN plus 1 equals VN, timesing by that rate there, then subtract the down payment. Okay, so that's my minus formula. Okay, it doesn't give me an interest rate this time. It says the interest is $180 per week. And take that out. And she makes weekly contributions of $410. So things you can do straight away is you could do over on the side is VN equals $345,000. D equals 410. And what you need is what the interest rate is. Okay, so this time it says part 1, calculate the interest rate of the loan. So it's just asked in a slightly harder way, but doesn't matter. The interest she pays is $180 per week. So let's think about that. She's paying $180 in interest out of the $345,000 loan, and I want my rate as a percent. So I'm going to times that by 100. And that will give me my value there. So you get a value of approximately 0.05217%. And I've just rounded that to 5 decimal places. I've done quite a few. The smaller you round, the fewer decimal places you round, it's less accurate you're going to be. So you always want to try and do a few if they don't mention it. Okay, if it was my HSC, I'd be doing at least 5 decimal places, at least. Okay, so that's the interest rate that they're charging. I've already times it by 100, so I have my percent there. So I know without the percent per week, this is all to do with weeks, remember, it's going to be 0.000517. So I've just divided that by 100 there, because we also for part 2 need it without the percentage. Okay, so let's fill it into my recurrence relation. So I'm going to have that VN plus 1 is equal to VN timesing by 1.0005217. Remember that 1 point, and I subtract off my 410. There is the formula of my recurrence relation, and now I can solve every one of these questions, no matter how many weeks they ask. It asks, in fact, how much does she have owing on this loan after 5 weeks, which means I need to go up to V1, V2, V3, V4, V5. Now, if you liked the setting out of the table, you could set this example answer out here entirely in the table like we did up here and just go to 5. Perfectly fine. Otherwise, if you don't want the table, sometimes it takes up a bit of time, but you can jump straight in. So the amount she takes the loan out for is $345,000. Multiply that by my rate and subtract off the 410. Now I haven't left myself any room, so I'm just going to do a double equals, which I don't really like, and put that into my calculator. Alright, so after the end of the first week, Ellie still owes $344,769.9865. And now again, what am I going to do? I'm going to bring that answer down and fill it in here. So the initial value and keep going. So keep going for me all the way down to V5. I'll pause the video here and do it myself as well. Okay, I got a bit lazy. Again, in your HSC, don't skip these lines, but I just kept putting it in my calculator rather than writing it out. But hopefully I did all that correctly, and hopefully you did too. So therefore, at the end of 5 weeks, Ellie still has this amount here, $343,848.73 owing on her account. Okay guys, so that is going to lead you perfectly into the rest of exercise 7A, questions 6 up to 12. I think it goes further than question 12, but you can definitely go further than that if you want a bit more of a challenge.